It's like they produced brownies. It's weird. And Nancy, I'm hungry. Okay. Oh, little barf brownie. All right. Sorry. Oh, Jeff. So what's supposed to happen with those amounts of brownies? They're supposed to add to be 18. What people do is people don't do any of this shit. They go 3 times minus 2. 3 times minus 2 is 18. Do you guys see why that is wrong? Yes. Because this would be who ate 18? This would be Nancy ate 18 all by herself, right? That's insane. Especially depending on what kind of brownies. So I'm supposed to, so what the people almost always do is they forget the one that's just the letter by itself because they focus so much. They know how, we did a lot of work with how to translate that into Mathish, right? Just that by itself. So your brain goes right to them. Don't skip this step because you always leave some poor little dude out. And that's when you get weird answers like 1.7 brownies or something, or negative brownies or something. So what should this be? It should be 3b minus 2 plus b. Good. And now that should be the easy step, right? Yeah, good. 3 and 4 is 4b. Add the 2, you get 20. Divide by the 4, you get 5. So Steve ate 5 brownies. And Nancy ate
13. Oh my God.
13 brownies.
Queen.
So Nancy.
I respect her so much.
So you guys have never had that friend that say, I got a couple brownies for you, and they're each like this big? You never had that?
Little brownie bites from like Albertsons.
You got a couple brownies? Oh, thanks so much.
Oh, brownie bites.
It's like a cubic centimeter of brownie mat.
Yeah, it's basically,
It's nothing.
it's a brownie particle. All right.
It's an iota of brownie. It's nothing.
I like
It's an
it.
insult.
Look at that callback. Iota, that's awesome.
Extra credit?
That's pushing it now. All right, so let me leave that up there. Okay, let's do, actually, let me see, I'm going to give you this.
This is the fun math class.
Probably the best one. I don't want to take it personal, but I know you wouldn't be here if you didn't have it. Back there.
It wouldn't be anywhere if it didn't have to be.
There's places I'd want to be. Oh, okay. That's very depressing, man. I'm sorry. Nihilistic. I don't want to be. How about you guys? Just because I'm really lazy. All right, so I try to make something that pretty much captures what we just discussed. So what am I trying to do here? Oh yeah. Oh. Yeah, can you turn out those ones? It's the top 2 and the bottom right. Yeah, dude, look at that. All right, thank you. So I give you 2 examples up here. There's one that's sort of like what we started with. So the first step is always, what are the players? Purely English. So the right way to do a word problem, you end up reading the problem a few times. And each time you read it, you get another level of information. So the first time you read through it, I don't give a shit about 23. I don't give a shit about 3 times or any of that shit. I'm just saying largest side, small, what does it say? Middle side and shortest. Use the exact same language the problem does, so it's easier for you to go back and forth. And it's easier for me to grade too. So. Which one is just x? That's the next really important step, right? So why did I make x the shortest side? Well, because the other 2 depend on it. So if you read through it, certain triangle, the largest side is 3 times as large. Middle side is 1 less than twice the shortest. If I knew the shortest, I know everything. So that's the one I make x. That's the one that everything depends on. Draw the picture, really good step. Not always. If the problem is a shirt is 20% off, don't draw a shirt. You can, but it's not going to help you. And then translate from English to Mathish. Right? So here's the picture. I've labeled it with all the stuff I figured out from the relationships. And then I've got my equation. The perimeter is supposed to be 23. Bam. Maybe. So if I try to show you, oh shit. Well, I try to show you the importance of the steps, and you've probably had teachers tell you some of these steps before, but I don't know if they necessarily made it clear why they were important and how they help you. Anyway, so there's that one, and then I have another one sort of like, this is the one sort of like that last one we did with Nancy and Steve, but just with less explicit brownies. There could have been brownies at this concept, I don't know, but they didn't come into this problem. So, let's see what time is it. Let's try, look on the back. These two at the beginning, I don't call them full word problems. They're like pseudo math. It's like somebody read an equation in English. Do you see what I mean? Those first two, I don't even count them as like full-blooded word problems. Because it's just one step away from being an equation already. So try to do number one. Yes? Yeah, there you go. Yeah. Oh, one thing though. There it is. Decreased by 10. So it should be, yeah. Okay. All right. So something that some of you guys were getting confused about in the homework. A number divided by 3. So what do you want to pick for it to be a number? Yeah, you can use n, x, it doesn't matter. I'll go ahead and just use x. You can use whatever number you want to, whatever letter you want to. Divided by 3. Everybody represent that. X over 3 equals, okay, that's a giveaway. The number decreased by 10. And what's the symbol you already chose to represent the number? X. So what's that decreased by 10? Yeah. All right, now this is supposed to be the easy step. The only fraction, there's only one fraction, so you can kill it directly. So what would you do first to both sides? Yeah, kill the fraction. Kill the what happened? Yeah, sure. Yeah. I didn't say an integer. I said a number. So the answer could be decimal fraction. Yeah. So let's see what we get. Multiply those sides by 3. Bam. So I get x equals 3x minus 30. Is that cool? Now you shouldn't get a fraction though, buddy. So what do I do next on this one? Say again? What's the only thing in the wrong place?
The 3.
The 3x. You guys see that?
Yeah.
So normally we try to keep the x positive, but here, shit, yeah, I'm going to subtract 3x because that's the only thing that's on the wrong side. Or all the numbers together. Yeah, so they claim that side. That 3x better get the hell out the way. Right? Get out the way. Move. X. All right. Do you guys see that? When I say that, that's a really good way to look at problems. You say, what is in the wrong place? 3 x's. All right, then move it. What do you get here?
Negative 2x.
Negative 30? 15, yeah. So you should get a nice 15. Didn't have to be a whole number, but it is. That's always nice. Okay, I like it. By the way, let's see if I can reproduce this. I'm getting too many people solving an equation like this. Let me see if I can think of what this would be. Yeah. Let's say it like this. I don't even have the 4 there. Let's just make it like that. All right, here's an equation, right? Okay. All right, can somebody tell me Does that look okay?
No.
What happened?
You just moved it over to the other side. No.
What happened was they didn't write what the result of what they did was. They just kind of, their brain went, that's a 5 and there's an x, the x equals 5. Next. I ain't got time for this shit, Mr. Walker. But follow, this isn't even the right thing to do, right? But if I did this, what would I get? X
X
plus 5 equals 0. So when you do something to an equation, you have to write the result of what you did. You can't just go, it's got this and this in it, so that must be the answer. Right? And then if you get there, you're like, well, I did the wrong thing. I was supposed to do what? Subtract 7. Right? But right there where we are, we can just subtract 5 and then be done with it, right? Okay, I like it. So I'm not talking to any specific person. There are a few people who do that kind of thing. Just be careful. Just don't do that. All right, I want to do one more of these. Try to do number, let's see, try to do number 4. Why not? Let's be ambitious. Life is unfair. Yeah, this is sort of worded bad here. A really, 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 really good step is to draw the picture and label it. One year I had some kids say, what country is Malcolm in meters? All right, shut up. So what are the players in this problem? I'm going to catch up to you a little bit. It's a little bit, tiny bit buried, but you can see it. What's the players? The yard. What are the parts that go into the idea? What's length and width? And that's why drawing the picture behind, the really important part is it's rectangularly shaped. And what are the important aspects of a rectangle? Length and width. So drawing that picture really kind of helps you focus on what the players are. What describes that shape? The length and the width. The perimeter, the 92 meters of fencing is going to be when I create the equation. That's what it's going to have to come out to be. So length and width. Which one is going to be just x? Why?
Because the length is 4 times.
Yeah, 4 meters longer, yeah. The length is 4 more than the width. I like it. Of course, the grammar on this is not math's fault, but you got to kind of tease out. The yard is 4 meters longer than it is wide, so the length is 4 more than the width. So if you call the width, what do you call it? W. I'm going to do W. Why? So what's the length going to be? W plus 4. Don't be evil to yourself and call the length L. There's no reason to do that because the length isn't independent of the width. It's dependent on the width. So you got to have W show up in both expressions. Does that make? Later this semester we'll have stuff with 2 variables in it. Yay. We're not yet. So the biggest mistake people make is this. Why is that wrong?
Because
4
there's
sides.
2. Yeah.
There's 4 sides, so I only went how far?
3.
I only went halfway. Here's the width. Here's the length. So I gotta have W plus W plus 4 plus W plus W plus 4. I like it. And you could do the 2 times thing, yes. You gotta have 4 sides. Look, I got 1, 2, 3, 4 sides. What I do, just to be different, and I'm a math geek, I would put W plus W plus 4, but then it would equal 46 because it's only halfway. But you don't have to do that. That would work. W plus W plus 4 is only halfway. Well, halfway would be 46, and that works beautiful because it describes the problem. You don't have to do that. So what do we do? Now it's just the easy step. 1, 2, 3, 4 W's plus 8, 92. Oh shit, what did I do? These buttons underneath here. God, every day I sound more and more like an old man. No, Jeff.
84.
Thank you. And then,
Oh, bye-bye.
21.
21.
21. So the width is 21.
And you have to put meters, right?
Have to. Thank you.
They gave you the units.
Gotta use units unless I don't give you any units. And the length would be
25 meters.
25 meters. How do you check that? We just double 25, double 21, add them together. 25 doubled is 50 because we got two lengths. 21 doubled is 42. 50 and 42 is 92. Yay! Or, you know. Yay. Yes?
Why are we going from working on like hard ass equations with the linear equations into this is easy?
Enjoy that. Today's the first day of word problems, right? So we will get to the point where we're incorporating discounts of percentages and yes. But this I just wanted to do relatively easy stuff that you actually could. Now here's the thing. One last thing. Some students do this by guessing the answer and they say, I got the right answer. Why'd you take off all the points, Mr. Waller? And I'm saying to them, because we are in algebra class. So guess what you have to use then? Yeah, so my favorite example is if you were in driving class and your final exam was to drive to the mall and you walk to the mall, call your teacher and say, I made it to the mall. You failed, dummy, right? So if you're in driving class, you probably got to drive. If you're in algebra class, you probably got to algebra just to make that into a verb. So algebra that shit up or else you're going to lose all the points. So on that note, that's enough for today, I think.